Hey everyone, and welcome. Today, we're going to build the ultimate local development environment for anyone working with cloud-native tech on a Windows machine. We're talking Docker, a full Kubernetes cluster, all running smoothly right on your desktop. Let's dive in. But hey, before we get our hands dirty, if you find this guide useful and you're into streamlining your DevOps workflow, do me a quick favor and hit that subscribe button for the DevOps Corner. It really helps us make more practical walkthroughs just like this one. So let's start with a problem I'm sure many of you have faced. You're a developer, you're on Windows, but the tools you absolutely need, we're talking Docker, Kubernetes, and that whole universe of command line magic, they're all built for Linux. So how do you bridge that gap without ditching your favorite OS? For years, this has been a huge headache, leading to some, let's be honest, pretty clunky workarounds. But today, Windows has a solution that is so slick and so integrated, it almost feels like magic. Let's take a quick look at how we got from there to here. You know, back in the day, your choices were pretty rough. You could dual boot your machine, which is just a pain, or you could fire up a heavyweight virtual machine with something like VMware or VirtualBox and just watch your RAM disappear. The modern answer? It's the Windows Subsystem for Linux, or WSL, and it completely changes the game. So what is this WSL thing really? Well, it's a feature that's built right into Windows, and it lets you run an actual, genuine Linux distribution, like Ubuntu, directly on your machine. This isn't some slow emulator. It's a super efficient compatibility layer that lets Linux programs run natively. And here's where it gets really important for us. The jump from WSL1 to WSL2 was massive. WSL1 was pretty clever. It tried to translate Linux system calls into Windows calls, but WSL2? It runs a real, honest-to-goodness Linux kernel in a super lightweight utility VM. This is the secret sauce because it gives us 100% system call compatibility, which is exactly what tools like Docker need to work properly. Docker needs raw access to kernel features, and WSL2 delivers that perfectly. All right, enough theory. Let's roll up our sleeves and actually build this thing. The very first step is to make sure the WSL feature is even turned on in Windows. Don't worry, this is just a one-time thing. Just pop open your Start menu and start typing Turn Windows Features On or Off. A little window will pop up. Just scroll down, find Windows Subsystem for Linux, check that box, click OK, and if it asks for a restart, go ahead and do that. Okay, with WSL enabled, you're going to open PowerShell or command prompts. And here's a key tip. Make sure you want it as an administrator. Then just run this one simple command, wsl-install. This little command does all the heavy lifting for you, installing everything you need, and even downloading and setting up Ubuntu by default. After the install is done and you've set up your new Ubuntu username and password, you can pop back into your Windows command prompt and run this command, wsl-l-v. This just lists out your Linux distros, and this is the important part, it confirms the WSL version. You absolutely want to see the number 2 right there. Awesome, our Linux environment is officially ready to go. Now, it's time for the main event, installing Docker. From this point on, we're going to be working inside our new Ubuntu terminal. First things first, anytime you step into a fresh Linux environment, it's just good practice to update your package lists. This makes sure you're grabbing the latest and greatest versions of software. So just run sudo apt-get update. Okay, now this next part looks a little intimidating, I know, but don't worry. These 4 commands are just a standard procedure to add Docker's official software repository to our system. We're just installing a couple of prerequisites, making a special directory for security keys, downloading Docker's key, and then finally telling our system where to find the official Docker packages. So, with the repository all set up, let's run sudo apt-get update just one more time to refresh our lists, and now we can finally install Docker. This command pulls down the Docker engine, the command line interface, and containerd, basically the whole shebang. But did it work? There's only one way to find out. Let's run the classic test. Sudo docker run hello world. This command tells Docker to download a tiny test image and run it. If you see a message that says hello from Docker, then you are officially in business. Okay, one last little quality of life fix for Docker that will save you a ton of headaches. You probably noticed we had to type sudo for that last command. To avoid doing that every single time, run this command to add your user to the special Docker group. You'll have to close and reopen your terminal for it to kick in, but trust me, it's so worth it. We have Linux, we have Docker, it's time for the grand finale. Let's install a fully functional single-node Kubernetes cluster right here on our machine using a fantastic tool called Minikube. Before we get Minikube itself, we need the remote control for our Kubernetes cluster. That tool is kubectl. It's the command line tool you'll use to interact with Kubernetes. And luckily, it's super easy to install. Just run sudo apt-get install-y kubectl. Installing Minikube is a quick two-step dance. First, we use curl to download the latest stable version as a Debian package. Then we use the dpk command to install that package right onto our system. Simple as that. And now, the moment we've been working towards. With one single, beautiful command, Minikube start, we are about to bring an entire Kubernetes cluster to life. So much is about to happen behind the scenes. So what's this one command actually doing? Well, Minikube is smart. It automatically sees that we have Docker installed and decides to use it. Then it starts pulling down all the necessary Kubernetes images, creates a special Docker container that's going to act as our Kubernetes node, and then it boots up the entire control plane inside that container. It's doing a ton of work for us. And that's it. It might take a few minutes the very first time you run it, but just like that, the setup is complete. You now have a full-fledged Kubernetes development environment running on Windows. Let's do one final check just to be sure. Let's use that kubectl tool we installed. In your terminal, type kubectl get nodes, and there it is. You should see a single node named Minikube with a status of ready. That is your proof. Your cluster is up, it's running, and it's ready for you to start building. So there you have it. A powerful, efficient, and fully featured cloud-native development setup, all running seamlessly on your Windows machine. The only real question left is, now that you have the power of Docker and Kubernetes at your fingertips, what are you going to build first?